All right, problem number 5 is a non-calculator problem. Let f be the function defined by f of x equals e to the x cosine x. Part A asks to find the average rate of change of f on the interval from 0 to pi. All right, average rate of change, another word for it, please remember, is just the slope. So just your y2 minus y1 over x2 minus x1. In order to find the slope, we are going to need to find y2 and y1. So we're going to need to find f of 0, and we're going to need to find f of pi. So to find f of 0, we will plug 0 in. So we'll get e to the 0 cosine 0. E to the 0 is 1. Cosine of 0 is also 1. So f of 0 is equal to 1. F of pi will be e to the pi cosine pi. E to the pi is just e to the pi. And then cosine pi is equal to negative 1. So this will equal negative e to the pi. Okay, so now we have our y values. So now we'll do y2, which will be negative e to the pi, minus y1, which will be 1, all over x2 minus x1, which will be pi, minus 0. So if I reduce that at all, it will be negative e to the pi minus 1 all over pi. So that actually is all we need to do for that. And we would get 1 point for our answer. Okay, part B, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? All right, slope of a tangent line is just the derivative. So we need to find the derivative of f of x. In order to do that, please notice that this is a product. So we will need to apply the product rule. So I'm going to label my f and my g. So f prime will equal e to the x, and g prime will equal negative sine x. And now I'm ready to find the derivative. So we'll get f prime times g, so e to the x cosine x plus f times g prime. And then I'm just going to rewrite this just to make it look better for my sake. So e to the x cosine x minus e to the x sine x. So that will be the derivative, and it asks us to find it at pi over 3 pi over 2. So now we're just going to evaluate it at 3 pi over 2. So wherever I see an x, I'll just put 3 pi over 2. Cosine 3 pi over 2 minus e to the 3 pi over 2 sine of 3 pi over 2. Okay, I'm going to go farther than this, but if you left your answer like that, since it's equivalent to the correct answer, we would get full points for it, but I am going to go farther, e to the 3 pi over 2. The cosine of 3 pi over 2 is actually equal to 0, and then we're going to have e to the 3 pi over 2. Sine of 3 pi over 2 is equal to negative 1. So the slope of this line would be positive e to the 3 pi over 2. Alrighty, we are going to get 1 point for properly taking the derivative, and then we're going to get 1 point for getting the correct answer. Okay, part C, find the absolute minimum value of f on the interval from 0 to 2 pi. Justify your answer. Justifying your answers is going to be the work that we're going to be showing. Absolute minimum. Please remember, to find an absolute minimum, we need to find the critical values, and then when we need to evaluate the function at the critical values and the endpoints. So the first thing that I'm going to do, we already found the derivative in that last part, and that was equal to e to the x cosine x minus e to the x sine x. To get a critical number, we want to set that equal to 0. And it would be nice if we had a calculator, but we don't. That's okay. Alrighty, and then what I did from here, I factored out an e to the x. And then e to the x, if you know that function, e to the x looks like this. It's never going to equal 0, so there will be no critical numbers for e to the x. So I need to figure out where cosine x minus sine x is equal to 0. And so I'm going to add sine x to both sides. So I'm going to get cosine x is equal to sine x. So now I just need to decide on the unit circle, where do the cosine and sine equal the same values? And I know they both equal the square root of 2 over 2 at values of pi's over 4. So my values are going to be at pi over 4. And then also it's going to be at 5/4 pi, because in the third quadrant, both values are negative. So if we divide them, we're going to get a positive answer. So those are the places. So now what I want to do, the justification will be, I'm going to evaluate at my endpoints, which will be at 0 and 2 pi, and then I'm also going to evaluate at the critical values. And notice we're going back into the original function. So f of 0 we already found was, what was it, 1. Okay, f of 2 pi, I'm going to get e to the 2 pi cosine 2 pi let's see, e to the 2 pi is just e to the 2 pi. And then the cosine of 2 pi is 1, so this will be e to the 2 pi. All right, f of pi over 4, so we'll have e to the pi over 4 cosine pi over 4. I don't know what e to the pi over 4, just going to leave that, but so this is going to be e to the pi over 4 times the cosine of pi over 4 square root of 2 over 2. And then e to the 5/4 pi, we're going to have e to the pi 5/4 over pi. And then we'll have cosine of 5/4 pi. So that will be e to the 5/4 pi times the cosine of 5/4 pi, since it's down in the third quadrant, is going to be negative square root of 2 over 2. And so then from here, we are going to end up getting, it asks us for an absolute minimum. So I need to know the minimum value. And I notice the only one that is a negative value is going to be happening at 5/4 pi. So that must be my minimum. So my minimum, absolute minimum, is equal to negative e to the 5/4 pi times the square root of 2 over 2. So that is my absolute minimum. Okay, if we set the derivative equal to 0, we're going to get a point. If we found that these two were candidates, we're going to get another point. And then if we were actually able to find the right answer and then had justification to back it up, we would get that third point. Okay, part D. This one looks kind of mean, but it really is not so bad. Let g be a differentiable function such that g of pi over 2 is equal to 0. The graph of g prime, so notice this is g prime, the derivative of g is shown below. Find the value of the limit as x approaches pi over 2, f of x over g of x, or state that it does not exist. All right, whenever I see something that has a fraction, I'm going to be thinking I might be able to use the L'Hopital's rule on this one, but first of all, we just need to see. So the first thing that we want to do if we're finding a limit, we're going to actually just plug in pi over 2 to see if we can actually just find an answer. Okay, f of pi over 2, we are using the same value. So to get f of pi over 2, we're going to get e of pi over 2 times cosine pi over 2. The cosine of pi over, this is going to be e to the pi over 2 times cosine of pi over 2 is 0, so that will be 0. And then g of pi over 2, they told me that g of pi over 2 is equal to 0. So notice we do get 0 over 0. So I am going to get to use L'Hopital's rule. But remember, when we're using L'Hopital's rule, we need to justify that we're going to get to use it. So I'm going to say, since the limit as x approaches pi over 2 of f of x is equal to 0, and the limit as x approaches pi over 2 of g of x is also equal to 0, we may apply L'Hopital's rule. Okay, so we've established that. Now I'm going to use L'Hopital's rule. So remember, for L'Hopital's rule, we're still going to have a limit. So the limit as x approaches pi over 2. And now we just take the derivative of the numerator and denominator. So the derivative of f is f prime. The derivative of the denominator is g prime. And now I'm all set to go ahead and do this. So f prime, we've already established from the last problem, was equal to e to the x cosine x minus e to the x sine x. And now we just need to plug in pi over 2. So that is going to give me, I'm going to try to put up here, e to the pi over 2 cosine pi over 2 minus e to the pi over 2 sine of pi over 2. Okay, so if I evaluate that, cosine of pi over 2 is 0, sine of pi over 2 is 1. So I'm going to get negative e to the pi over 2. Okay, so that's the numerator. Okay, g prime, so now I'm going to be looking for g prime of pi over 2. Please remember that this is g prime. So g prime at pi over 2, I'm really just looking at the y value up there, and that y value is equal to 2. So I didn't get 0 over 0 again. I actually got an answer. My top answer was negative e to the pi over 2, and my denominator answer is 2. And I don't need to simplify from there. I was able to find a limit. So I would get 1 point for finding that my limits are equal to 0. So I found that my limits were equal to 0. So I get a point right there. I'm assuming that I'm going to we'd have to say that. It also says in here that we should have said something about g being continuous. So if g is differentiable, it was continuous. So I'm just going to say g is continuous, just in case. All right, so we've said that we can use L'Hopital's rule. Up here, I actually used L'Hopital's rule, so I showed that I was taking the derivative of the numerator and the derivative of the denominator, and then I get 1 point for getting that right answer. So number 5 is done.